Hey guys, we're going to talk about a couple of topics today, one of them being difference of squares. So difference of squares means that we have a subtraction and then perfect squares like 1 is a perfect square because it's 1 times 1. 4, 2 times 2. 9, 3 times 3. 16, 4 times 4. 25, 5 times 5. 36, 6 times 6. And the list would keep going and going. So to factor a difference of squares, x squared is a perfect square minus, there's the subtraction or the difference, and I could pick any one of these numbers to put next. So let's say it's 4. So I can factor this into x plus 2, oh, you can't see that, x minus 2. And I can do that because I would be looking for the factors of negative 4 that add to 0, because there's not an x term. So it's kind of like if I rewrote it as x squared plus 0x minus 4. That's why we're looking for the 0 in the middle. So I wouldn't be able to do this positive 2 times negative 2. I wouldn't be able to do this with any other number than a perfect square, because we wouldn't get a multiple and a 0. So I'll show you that a couple more times. We'll just factor the difference of squares. Let's say x squared minus 9. So 9 is 3 times 3. So I'm going to use a positive 3 and a negative 3. And I have to use a positive times a negative because this is a negative 9. We would need factors of negative 9 that add to 0, because again, there's not that middle term we're used to seeing. So you get a positive 3 and a negative 3. And then another one that's going to come up a lot in our practice today, x squared minus 1. And that's a negative 1 would be a positive 1 times a negative 1. So that is the difference of perfect squares. And we have to watch for this coming up in the second part of the mathematics we use to factor quartic trinomials. All right, so the next thing we discussed in notes number 2 was how to factor a quartic trinomial. Quartic tells me that it's x to the 4th, and trinomial tells me there are 3 terms. We discussed this a little earlier this semester with how the names of polynomials go. So I'm going to do an example for you. Let's do so the directions will just say factor. It won't be too much more complex than that. So we'll factor x to the 4th plus x squared minus 20. So in the lesson that we did yesterday, this looks familiar. We're going to pretend for a minute that these extra x's aren't in there, that this is an x to the 4th. We're going to pretend for a second that this is x squared plus, we're going to take 1x minus 20. Because when I take those extra x's away, well, now this is quadratic, and I'm used to looking for factors of 20 that add to a, so there's not a number here with this x, but I would use a 1. So let's say 5 times 4 is 20, but it's got to be a negative 20, so I'm going to have opposite signs, a positive and a negative. So I'll write x plus 5 and x minus 4. But in this answer that I have so far, I only have 1, 2 x's, and originally there were 4. So I have to put the extra x's back in. And I have to be fair about it. So I'm going to put 2 here and 2 here. So the trickiest part about this process is that we have to double check each parenthesis for a difference of squares. So remember, the difference of squares has to have a minus sign and a perfect square number, and we discussed those a little bit ago. So in x squared plus 5, well, I have a plus sign, so that's not going to factor more. That is not a difference of squares. But over here, this is a minus, and 4 is a perfect square. It's 2 times 2, or I'm going to use a positive 2 times a negative 2 in order to make that negative 4. So we keep x squared plus 5, and we factor this difference of squares. It becomes x plus 2 and x minus 2. And then here at the end, I just double check. So I've got 1, 2, 3, 4 x's. And I was supposed to have 4 x's at the beginning. So that's how I know I have all of the pieces that I started with. And that will be your final answer. So let's do that again. We're going to factor. Let's do x to the 4th minus 6x squared minus 16. So I pretend that it's not x to the 4th. I pretend that it's x squared minus 6x minus 16. And I'll factor. Factors of negative 16 that add to negative 6. So let's see, 16 is 8 and 2. I would get a 6 out of that somehow. Now, looking at this sign right here, that tells me that the bigger number is going to be my negative because this bottom number is negative. And this one will be positive. So I have x plus 2 and x minus 8. Don't forget to put the extra x's back. So I put 2 here and 2 here. Now I have to go through my checklist to see if either one of these parentheses can be factored more. So what I'm looking at first is there a minus or subtraction sign? So nope, so I can't factor that one anymore for sure. And then over here, I see that I do have a minus sign, but then the second thing that has to check off on my list is the number after that minus sign is a perfect square, like 1, 4, 9, 16, 25, that special set of numbers we've been discussing. So is 8 a perfect square? Nope. So neither one of these can be factored more. That tells me that x squared plus 2 and x squared minus 8 is my answer. It couldn't go further. And that's okay. All right, let's do one more. So I have x to the 4th minus 10x squared plus 9. I pretend x squared minus 10x plus 9. So I'm going to find factors of 9 that add to negative 10. So 1 times 9 is 9, but since I have a negative down here, that tells me they're both negative. So a negative 1 and a negative 9. X minus 1, x minus 9. Please, please, please don't forget to put the extra x's back. So I'm going to put 2 here and 2 here. Now I'm going to go down my checklist to see if I have a difference of squares. So again, the first thing I check, is there a minus? Oops. Is there a minus sign? So this one's got a minus sign and this one's got a minus sign. Okay. Next, I check, is the number a perfect square? Like 1, 4, 9, 16, 25, and so on. So, oops. Like 1, 4, 9, 16, and 25. So looks like yep, 1 is a perfect square and 9 is a perfect square. So I can actually factor both of these further. So this will factor into x plus 1, x minus 1, and this will factor into x plus 3, x minus 3. So all of these pieces would have to be in my answer. And that kind of makes sense because if I had 4 x's to begin with, I see I have 1, 2, 3, 4 x's at the end in my answer. All right, guys, thanks for watching, and you have some practice in Delta Math today.